Let's talk about naming branched chain alkanes with two or more different substituents. So if you've been watching my channel, you'll notice that I talk about one substituent. I'm giving you the different type of alkanes that you can encounter. So when I'm finished, it doesn't matter which alkane you have, they will fall into one of these rules. Okay. So as usual, I've written down the three rules that you will use to name your alkane with two or more branch substituents. And I'm going to use these two structures, they are the same, right? To explain to you how you name a branch alkane with two or more substituents. First and foremost, let us establish that this is a branch alkane with two substituents. These are the substituents. And of course, our first thing to do is going to be to find our long chain. So this is your long chain in this molecule. If you have forgotten how to do long chain, I have a video on that. So that's my long chain, right? And the two substituents that are bonded to this continuous chain of carbons is this and this. So yes, I have a branch alkane with two substituents. So I have already identified the long chain. The next thing you have to do now is assign numbers on the carbons of the long chain, clearly. We spoke about this before, right? On the carbons of the long chain, so that the substituent you encounter first gets the lower number of the two, right? You number this chain so that the substituent you encounter first, because we have two of them, gets the lower number. That's one way to look at it. Or you could also say you number the chain so that the first substituent receives the lower number. Whichever one works for you, run with it, okay? So, and clearly, if this is my long chain in this molecule, it's also the long chain over here. What we're going to do now, we're going to do our numbering. Always remember, you can only number from my left. And what I mean by that, you start number one on the left hand side. If I start number one on the left hand side in this molecule, clearly I will start number one on the right over here. Let's do another color. So that's what I mean by when I say we number from my left to right, and clearly the other one you number from your right to left. Once you do left to right, right to left, that's the only way you can put the numbers into your long chain and determine which one is lower. There's no other way to number. It's left to right or right to left, right? So let's look at what happens when we go from my left to my right. So when I go from left to right, which is in this structure, right? If you notice, the substituent I encounter first is on carbon number 2, right? Over here, when I go from right to left, or when I number with the red numbers, the substituent I encounter first is on carbon number 3. So guess what we're going to do? Clearly, the rule says it must be the substituent you encounter first must be on the substituent you encounter first must be on the lower number. So tada, this is the numbering we're gonna go with, not that. Okay. Now there's another long chain in this molecule. Get in the comments, let me know if you see it, and let me know if we will also get the same name if you draw that other long chain. So now that we've done rule 1 and 2, the next thing we need to do is that we must list the substituents in alphabetical order. We have two substituents here. This is a methyl group and this is an ethyl group, right? This is 2 carbons. If you don't remember how to name your alkyl groups, there's a video for that, okay? Now, the first thing we did was identify our pairing chain, right? When you identify your pairing chain, generally, which is what I taught you in the first video, you write it down. So it's hexane, right? 6 carbons, we have an alkane. Now, rule 3 says you need to list your substituents in alphabetical order. All right. First and foremost, your ethyl group is on carbon number 4. Remember, once you write a substituent, it must have a locant. And the locant is the number, the carbon number that the substituent is on in the long chain of carbon, right? So 4 here is a part of your carbon chain. It's carbon number 4, and your substituent is on 4. So you must identify the carbon of the long chain that the substituent is on, which is 4. You cannot write a substituent without a number because it has to be on a carbon in the long chain. So you write 4 ethyl because E comes before M in the alphabet. We need to write methyl, but remember you must locate where it is. Every substituent must have a locant. Okay, don't forget that. It's on carbon number 2, so you write 2-methyl hexane. Remember, your letter and numbers must be separated by a hyphen. Okay, here I'm separating the letter and number by hyphen. If you don't do that, the name is not correct. Okay, so you have to do that. All right. Now, that was simple, no tricks in this one. But what if you run into a situation where, right, when you number left to right, right to left, the substituent you encounter first is on the same carbon. So let's look at that. Let's say I go 1, 2, 3, 4, 5, 6, 7, right? Over here, 1, 2, 3, 4, 5, 6, 7. So look, we have a different situation now, yes? If you look at the first structure, right, the substituent encounter first is on carbon number 2, right? Go over to me numbering from my right to my left. Substituent is also on carbon number 2. So you're like, okay, what am I supposed to do now? It's okay. Don't panic. Simple. All you have to do, the second substituent, you pick the structure that gives you the second substituent with the lower number. Okay? So for example, if we look over here, right, your second substituent, because this is one, this is the other one, and that's the other one. Your second substituent here is on 5, right? Over here, your second substituent is on 1, 2, 3. The second substituent is on 3, right? First one was here on 2. The second one is on 3. So 2 was for the first one. 3 is for the second one. Okay? So what are we going to pick? That one, because the second substituent is on 3 here. The second substituent is on 3 here, while over here, the second substituent is on 5. So no, we're not going with this at all. So how do we name this? We have 7 carbons in our longest chain. So 7 is heptane, right? All carbon single bonds. And then, which my next slide will take care of when you have the same substituents. But we're gonna do a little thing quick here. So you have a substituent on 2, you have one on 3, you have one on 6. They're all the same. They're methyl groups, right? Remember, you must locate every single substituent. So here it's gonna be 2. I have another one on 3, and I have another one on 6. It's 2, 3, 6 trimethyl. And like I said, I'll talk to you about tri and di in the next slide. All right, so it's trimethyl heptane. All right, so you can see this, it's trimethyl heptane. All right, I'm going to give you one last scenario, okay? What if you run into this situation, right? I'm going to duplicate this. But if you run into this situation, even more interesting than the one we just did, your usual, find the long chain and number it, all right? So let's do our number from my left to right. All right. And that's my left to right. Let's come over here and do right to left. You see what's happening over here? Look, your substituent encounter first over here is 3. Your substituent encounter first over here is 3. The substituent encounter first over here is also 3. Is also on carbon 3. That's what I mean when I say 3, right? Your second substituent in this structure is on carbon number 5. Then look what's happening over here. Your second substituent in this one is also on 5. So you're like, okay, at this point, lady, what do you want me to do? Here's what you do. Since it doesn't matter if you number left, right, right, left, you will still end up with 3, 5. First on 3 in both cases, and the second on 5. Guess what? What do you think you're going to do? It's in rule 3. You're going to use the alphabet. You pick the substituent that is lower in the alphabet that is associated with the lower number. So let me explain that. So here we have a methyl group on 5. And this is an ethyl group. And in this one, it's on 3. Your ethyl group over here is on 5. No. So you pick the one where the substituent that is lower in the alphabet also has the lower number. So to name this, right, and remember, you still list in alphabetical order. That is still the rule, okay? So it's going to be ethyl is low, E is lower than M. So it's going to be 3 ethyl, 5 methyl, and of course you can always write your pairing chain first. And this is basically how you name um a branched alkane with 2 or more substituents. I've given you the possible scenarios. Key to naming: practice, 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 practice.